Hi guys, this is Nazmus Simab and you're watching GetWays Solution. In this video, I'm going to solve a lead code question, merge to sorted list. So without any further delay, let's jump into the question. So question given is like this. So we have two lists and both of them are sorted and we need to merge them. Suppose we have list 1, 2 and 4 and 1, 3 and 4. So merge list will look like 1, 1, 2 and then 3 and 4 and then 4. So it will look like this. So we are going to take this example and we are going to first understand in whiteboard and then we will solve this question. So yeah, so this is the example. So here input list 1 is 1 2 4, list 2 is 1 3 4 and output is this. So how we are going to deal with this? So if we go to more detail, so we have other detail. If suppose one list is empty, then we need to return the list which one is which has some element. Okay, so if both are empty, then we need to return empty list. Okay, so let's jump into the question. So here we have input list as 1 to 4 and list 1 as 1 to 4 and list 2 as 1 3 4. So what we are going to do, we are going to take one new list where we will store the smallest element, smallest node. So suppose we are going to take uh, temp. Let's call it list temp. So in this, we will compare first two and which one is the smallest, we will take it. So in temp, we are going to store one first and then first our pointer will be at the first point and then we will our pointer will move to next. After storing, we will move the list from which we have taken the element. So we have taken the element from list 1 right now. So we move the pointer to pointer of list 1 and again we are and the pointer of list 2 will be here. So to be more clear, I will explain once again. I know I messed up. So I will explain once again and it's quite easy. You will get it. Uh, so suppose we have element 1, 2 and 4 in list 1. Okay. So 1, 2 and 4. And in list 2 we have element 1, 3 and 4. 1, 3 and 4. So list one pointer, first we will take two pointer, we will point to the initial of both of the list and we will compare which one is the smallest. We will create one new list called temp or something like the some name. So we will store the first value. So here we have we have taken the first value as 1. You can take either of it. So from whichever the list, suppose this is list 1 and list 2. Suppose from list 1 we have taken 1. So we will update the this pointer of list 1. So now this pointer will point to here. Pointer of list 1 is pointing to here. So now in next step, in next iteration, we will compare L1 to the L2. So here L2 is the one. So L2 is the smallest. So we will take the element of L2. So here L2. Now we will update the pointer of L2. L1 will remain there. Like last time L2 was L2 didn't move. So now L2 will move. Now L2 pointer is at 3. So in next iteration, we will compare L1 and L2. And since L1 is the smallest, so we will take the L1 element and we will update the L1 pointer. So now L1 is pointing here at 4. So we will update here the element and now we will compare L1 and L2. In L1 and L2, L2 is the smallest. So we will update the L2 pointer and we will take the element as 3. In next iteration, we will again compare L1 and L2. Since both are same, we will take any of it. So we have taken 4. And now in this iteration, you can see that this is at null and we already reach for L1, we already reach null. And for L2, still we have this element. So after iterating, we need to make sure that we need to add the remaining element. So after completing the iteration, if any one of the list reach to null, so in that case, what we will do, we will add add one last remaining value, whatever the remaining. Suppose this list will suppose in this case list is 3. Suppose list size will be like we have in list 2 we have more element like 5 6 7, so we need to add those element also. For right now we are leaving that. So after that we have remaining 4, we will add this, whatever remaining we will add this. Since one list is already reached to null, so the remaining list is already sorted, so we will add the sorted list. So this is the way uh, by which we can approach, we can write the code. So I will try to write pseudo code first. I will try to write pseudo code. I will delete these things. Okay, so here I will write pseudocode. So I will run a while loop and I will go till the null of both the list. So list 1 and list 2 we will check list 1 not equal to null, and then list 2 not equal to null. If either of the list become null, uh, we will come out of this loop, and we will check a condition. If L1 dot value of L1 is less than L2 dot value, whichever is minimum. So we will introduce one, suppose one node called current node, and in this node we will add this L1 if L1 is small. So current dot next we will add equal to L1, and we will update L1 also. L1 equal to L1 dot next. Since we have taken the value from this list, so we are updating this particular list. In other case, that means either L1 equal to L2 or greater than equal to. In both of the case, we will do current dot next equal to L2, and similarly we have taken value from L1, so we updated L1. So in this case we are taking value from L2, we will update L2. So L2 equal to L2 dot next. So after doing any of these operation, like we have added L1 to current or L2 to current, in both the case we need to update current, right? So that in current will be ready for the next iteration. So current dot next. So this complete our this much solution. So I told you that it at last might list contain a remaining element, so we need to add those element also. So at last we need to check condition. If L1 not equal to null, in that case we need to add it to current dot next equal to L1, and L1 equal to L1 dot next. And similarly we have to do for L2. So hopefully you understood the solution. Now I will directly jump into the code and we'll see that how to do this. So we have list 1 and list 2. We need to introduce one new list so that we need to keep it keep track of it, and we need to store the uh, value, sorted value, new sorted value. So we will call this as current, and we are going to keep as like we at last we want to return the head, so we are calling it as current head. So current head new list node, we are creating new object, so with the value 0. So this is a empty linked list. So in this I am going to list node, I'm going to create one current, and we are going to assign the head to the current, and the current head is this node. So yeah, hopefully you are guys are getting what I want to say, because I want to tell that if we will take only, if we will introduce only current, then current will be at the last node. So when we will return current, so we will return the last node, but we want to return the whole linked list, so we need to keep track of the head also. So that's why we have created head, and we assign that head to the current, and now we will iterate the current. So hopefully you guys are getting what I want to say. So Let's go ahead, and here I will write the while loop to iterate linked list. And by now, if you are I'm solving this question exercise. I'm taking exercise option here. If you go to the explorer, you will find a linked list. So, and in exercise option, this is probably like second last, third last question. So by now you need to be master on this linked list, because it is like little bit advanced question. So you need to know like how to iterate a linked list. So it is easy. Like here you need to go to you need to run a while loop, and we need to check like unless list one not equal to null, and this is a classic way to iterate linked list. So list 2 not equal to null, then go ahead and check this condition. If list 1 dot val is less than list 2 dot val, if this is the condition, then our current dot next will be list 1, and we will update the pointer of list 1 as we discussed in whiteboard. So list 1 equal to list 1 dot next. And if this condition not met, which means list 2 is the smaller, list 2 element is the smaller, so we will do current dot next equal to list 2, and we will update list 2 pointer of list 2, because we are taking element. In this case we are taking element from list 2, so we will update the pointer of list 2 dot next. And no matter whatever the condition, we are taking either list 1 or list 2. In both the case we need to update current for next iteration. So current equal to current dot next. So after doing all this, these whole thing will do the sorting, unless one of the list become null. If one of the list become null faster, then what to do with the remaining element of another list? In that case we need to give a condition. If list 1 not equal to null, in that case current dot next equal to list 1, and list 1 equal to list 1 dot next. And if list 2 not equal to null, in that case we will do same as we have done for list 1. So current equal to current dot next equal to list 2, and list 2 equal to list 2 dot next. So after doing all the operation, we need to return what? We need to return head, not the current head. So return, that's why we have taken current head. Return current head. Hopefully everything works fine. Let's run the code first, later we will submit. 0 1 1 2 3 4. So we need to return current head. So we don't have to return current head, we need to return current head dot next, because first element we have given 0. We have initialized list node now. In that we have initialized it with 0, so we need to give next. Hopefully now everything will work fine. Yeah, so it's 112344 112344. Let's submit our solution and hopefully it will get accepted. Yeah, so this is the solution. In this, we have used one extra space, and that is we have initialized one new linked list. So time complexity is O, the space complexity is O of n, and we have used one while loop. So time complexity also O of n. Thank you. So let's see more detail also, like how we performed. So we are memory uses be 22.49% of Java submission and no information about space. Okay, nice only. We have satisfied all the condition. I don't think like there is any condition mentioned like you need to do in O of one space or in place operation, anything like that. Nothing is there. If you see the condition, there is nothing like that ki you need to do in O of one space. O of n is fine, I think, for this question. Thank you. We'll meet you in next video. Bye bye.